All right, today's topic is right triangle trigonometry, and the first topic that we'll talk about, the first subtopic, is Pythagorean theorem, which I'm hoping will be a review for you. So the first thing that we need to do is we need to discuss how to solve problems that have square roots in them. So for example, in question number 1, it says x squared equals 16. So in order to solve this problem, in order to cancel out the square, I'm going to do the inverse of squaring something, which is square rooting. So I'm going to square root both sides, and you end up getting x equals 4. Okay? And then same thing with question number 2. Square root both sides, you end up getting a equals 3. Now remember, technically, you should get x equals plus or minus 4 and a equals plus or minus 3. But with Pythagorean theorem, we're going to be using it to find sides of right triangles, and we can only have positive numbers, so we'll only worry about the positive answers. So the next thing that we need to discuss is what a right triangle even is. So let's write down the definition of a right triangle. It's a three-sided figure with a 90-degree angle. Which I'm sure you guys all know. So if you're to look at the picture of it, I'll show it so you can get this down right here. Here is your right triangle. We have the box in the corner to indicate that it truly is a right triangle. A and B are called the legs of the right triangle, and C is called the hypotenuse. It's the longest side of your right triangle. So make sure you indicate that it's the longest side. Okay? And Pythagorean theorem says that a squared plus b squared equals c squared. So we are going to write down a squared plus b squared equals c squared right in this box right here. And that is called the Pythagorean theorem. So the next few questions ask us to indicate whether the following are right triangles. So in order to see if something is a right triangle, it has to satisfy the Pythagorean theorem, which we just figured out was a squared plus b squared equals c squared right here. So what we're going to do is we're going to plug in our information into that formula. Let's do question number 4 together right now. So the question is, though, which one of these sides is going to be the C? Now, if you remember, we discussed previously that the hypotenuse is always going to be the longest side. So out of all three of these numbers, 13 is going to be the longest side, which means it's going to be the hypotenuse. So when I use a squared plus b squared equals c squared, I end up getting 5 squared plus 7 squared equals 13 squared, okay? Which means that you get 25 plus 49 is equal to 169, which is not true, which means that it is not a right triangle. So this right here is no, it is not a right triangle. Okay, now if you look at question number 5, which one of these three terms is going to be the C value? Well, first of all, you could plug in radical 27 into your calculator, but I want you to think about it logically. What number would you square root to get 3? You would square root 9, right? So 3 is the square root of 9, and 6 is the square root of, you should hopefully say 36, which means that the square root of 27 falls somewhere between 3 and 6. Also, the square root of 27 is somewhere between the square root of 25 and the square root of 36, so it would be like 5 point something. So that means that C would be the 6 right here. So let's go ahead and see what happens when I plug in this information. So right here, you should get 3 squared plus radical 27, all of it squared, and make sure you have that in parentheses, is equal to 6 squared. So 3 squared is easy, that's 9. But what's radical 27 when you square it? The radical and the square will cancel each other out, so you end up getting just regular 27 is equal to 36. You end up getting 36 equals 36, which is a true statement, so yes, this is a right triangle. Please try questions 3 and 6 and come back to me and see how you did. So in question number 3, you should end up getting 25 equals 25, which is a true statement. Therefore, yes, it is a right triangle. Okay. And then in question number 6, you should end up getting 20 is not equal to 81, which is a false statement. So we're going to say no, this is not a right triangle. So now for the following questions, it asks us to find the missing sides in the following right triangles. So we know for a fact that it is that these are right triangles, so we don't have to determine whether or not they are. And we know because we have this right angle box in the corner. So now because we know it's a right triangle, we can use Pythagorean theorem to figure out what the missing side is. So again, a squared plus b squared equals c squared. We know for a fact that this has to be the C right here because it is across from the right angle. Okay, it's also the longest side, but you don't want to just look at it and assume it's the longest side because it's not always going to be drawn to scale. But we do know that this is the C value because it's across from the right angle. Therefore, this 5 and this 12 are interchangeable. They are both the legs, so I can use either one of these for A or B. So I'm just going to say that A is 5, so I'm going to say 5 squared, plus B is 12, so 12 squared equals x squared. So I end up getting 25 plus 144 equals x squared, which means that 169 equals x squared. Now I can square root both sides in order to solve for x, which means that x is plus or minus 13, but I only care about the positive side because we're talking about the length of a side of a triangle. Okay, so now let's look at number 8. For number 8, I want you to identify what the hypotenuse would be. Hopefully you said that the hypotenuse is this radical 17 right here because, again, it's across from the right angle. So we're going to use Pythagorean theorem again. A squared plus b squared equals c squared. And I'm going to say that this is the c value. So 1 and x can be interchangeable for a and b. So I'm going to say 1 squared plus x squared equals radical 17 squared, and hopefully you remember your parentheses. Please be careful. Don't tell me that 1 squared is 2, because 1 squared means 1 times 1, not doubling 1. So I end up getting 1 plus x squared equals, remember, if I have a square root and a square, they'll cancel each other out, and I end up getting 17. Subtract the 1 from both sides, I end up getting x squared equals 16. Square root both sides, and that means that x is plus or minus 4, but again, I only care about the positive value. All right, last question for this topic. Number 9. A 5-foot ladder rests against a 4-foot vertical wall. How far from the wall is the foot of the ladder? So we need to draw a picture in order for this to work for us. So remember, when you draw a ladder, your ladder it's not going to be vertical, and it's not going to be horizontal, because if you have a vertical ladder, it's not really going to be helpful, and if you lay it flat on the ground, it's not going to be helpful either. So it's your diagonal, which in this case is going to be our hypotenuse right here. So here's my wall, and here is my ladder. So I know my ladder is 5 feet long, and I know that the top of the ladder reaches a point 4 feet above the wall. Okay, or 4 feet on the wall. And then it says, how far away from the wall is the foot of the ladder? Well, here's the wall, here's the foot of the ladder. So I'm trying to find this horizontal distance down here, so I'll call this x. I know that this 5 is the hypotenuse because this is my right angle right here. So I'm going to say 4 squared plus x squared equals 5 squared. I end up getting 16 plus x squared equals 25. Subtract the 16 from both sides, I get x squared equals 9. Square root both sides, and then you end up getting x equals plus or minus 3, but we only care about the positive again. And then because this is a word problem, we got to make sure that we label our unit. So our answer is that it is 3 feet. The foot of the ladder is 3 feet away from the wall.